this is where it does get a little bit confusing. Okay, this is the harder part. However, try to keep it as simple as possible. Okay, so here is what we want to remember is probability is basically the number of ways I win divided by the number of things that could happen. And a lot of times you have to use permutations or combinations to do these things. And so you got to make sure if it's a combination problem that you use a combination. If it's a permutation problem, you use the permutation. Okay, so the first thing is 4 boys and 3 girls line up at the classroom door to be excused for recess. Find the probability the first person in line is a girl and the last person in line is a boy. Okay, so first up we're going to do is find the denominator. Total number of ways that this could happen. All right. Okay, so five. Okay, so you said 7. How many ways could 7 people line up at the door? So the first person in line could be any of the 7, right? And then the next person could be any of the 6 left. And then next one is any of the 5 left. And then there's 4 left, and then there's 3 left, and there's 2 left, and then this line finally has 1 person left in it. So that actually is 7 factorial, which is equal to 5,040 ways. Okay, 5,040 ways. And then the numerator, whatever. Okay, so the numerator, the first person in line is a girl. How many girls are there? There are 3 girls. So it doesn't matter which girls, but one of those first 3 needs to be a girl. Okay, and then the last person line needs to be a boy, so there's one of the 4 boys there. Alright, so the first person in line is a girl, the last person in line is a boy. How many kids now do we have left? How many kids can be second in line? We got 1 here, we got 1 here, so we've used 2 kids already, so there's only 5 remaining, and then there's 4 remaining, then 3, then 2, and then 1. So that is, let's see, that's 8, 24, 20 is 480, I don't know, 144, 1,440, I don't know, 3 times 5 times 4 times 3 times 2 times 4. Yep. So that's 1,440 ways that they could line up with a girl first and a boy last. So the probability is equal to 1,440 divided by 5040, which comes out to be, and I don't, sometimes they want decimals and sometimes they want fractions, so make sure you have a calculator that switches back and forth. But if they want decimals, maybe 3 or 4 decimal places. If they want fractions, I think this is 2 sevens. Yeah. So 2 sevens. Okay, so that's basically, huh? Okay.
So there's 7 people. One in the front, one in the back. That's 2.
I think it's just lucky that that worked that way. Okay, so that's the thing. Find the denominator, find the numerator, simplify the fraction. All right. 6 jokes, 1 each by Groucho Marx, Bob Blitzer, never heard of him, Stephen Wright, Henry Youngman, Jerry Seinfeld, Phil Stiller. The order with the cards are drawn determines the order in which the jokes are delivered. What is the probability that a joke by a comic whose first name begins with G is told first, and a man's joke is delivered last? Okay, so.
Wait. They're all men.
Phyllis Diller is a woman. Okay, so let's do the denominator first. And it's, I don't know which joke comes first, but there's 6 possibilities. Then times 5, 4, 3, 2, 1, which is 6 factorial, which is 720. Okay, then the numerator, we have 6 jokes. 3, 4, 5, 6. The first one is a comic whose name begins with G. Well, there's only one guy, right? That's Groucho. Okay, and the last one is delivered by a man. How many men are there? Five, but we've already used Groucho, so only 4 men left. Okay, so of the 6 people, we've already used 2 of them. We've used Groucho and 1 of the other men. So there's only 4 people left. So 4, 3, 2, 1. And we multiply those together. 824 times 4 is 96. So we have 96 divided by 720, which would simplify to something. 96 divided by 720. 0.13 repeating, which is equal to, what is it, 2/15. I went the wrong direction. 2/15. Okay. Martha, Lee, Nancy, Paul, and Armando, 1, 2, 3, 4, 5 people, all invited to a dinner party. They arrive randomly, which means we don't know which one's going to arrive when. We don't know if one is always late or always early. We just, okay. And each person arrives at a different time. And how many ways can they arrive? This is the denominator if you don't recognize this. This is the denominator. Oh, that's probably going to be in a different format.
That's awful.
Here, why don't you try these?
Yeah, I don't like that calculator.
This is the one that you're going to have on test day. So 120. So make sure you know how to get to factorial on these yellow calculators. It's 5. Did you use the? I don't know where it is.
It's right here in the bottom corner.
Nice. Okay, so 5 factorial. So it'd be all 5. Any of the 5 could arrive, and then any of the 4, 3, 2, 1, which is 120 different ways. We're multiplying. Okay. Now, how many ways? So the next thing is the numerator. How many ways can Martha arrive first and Armando last? So We got Martha first, and then 1, 2, 3, and Armando last. So we don't know about the middle three. 3 times 2 times 1. Well, that is actually just what, 6? There's only 6 ways for that to happen. That Martha arrives first and Armando arrives last. So the probability would be 6 over 120, which is 1/20th, which is 0.05. How do you change it from a fraction to a decimal in this calculator? I don't either. Probably ought to figure that out for the next test. Or actually, I don't care if it's in fraction form.
I don't remember.
I'll find out. Yeah,
Okay, so it just goes to,
no idea.
I don't remember. Someone showed me before, but I don't know how to write this hardly. Like the basic easy stuff.
Is there an escape button? Oh well. Okay. The answer is 1/20th or 0.05. Okay. There are a couple of lottery problems on your homework, and they are extremely fun to do. Okay. So they're really hard, actually. Okay. So remember, we're doing number of ways we win over total number of things that could happen. So we got to figure out the denominator. You choose 5 numbers from 70, and then a Powerball from the numbers 1 through 25. So the denominator, 1, 2, 3, 4, 5, right? And then the Powerball over here. Okay, so this first one that's drawn can be any one of the 70, right? And then the next one that is drawn can be any one from the 69 left, then 68 left, then 67 left, and 66.
And this one can be any of the 25. What are the 20?
Any of the 25. Now the question is, does order matter up here? No. So we did this wrong, because the order doesn't matter. We put them in order. We put them in. We did a permutation. It's just supposed to be a combination. So we're going to need to do a combination. This is going to be good. This is going to change your life right here if you didn't know this already. Combination of 70, 5 times, well, a combination of 25, 1. But that is just 25. There's only 25 ways to pick one ball from a group of 25. So this is 25 here. But it's this one that's weird, the 70, 5. Did you know that in your calculators, see if I can find it, menu, come down to probability, and right there is combinations.
Wow.
And then you just put in,
Oh, no, not permutation.
don't do permutations, 70, comma, which I don't know where the comma is.
Right here.
Got it? And 5. 70, 5. And that is a bunch of numbers. 1, 2, 1, 0, 3, 0, 1, 4. So those people who watch this video or come to this class will know that this calculator has a nice little thing for combination and permutations. You no longer have to use the formula. All right, and then I'm going to take that number and multiply by 25. And I get 3, oh, is it 30 or is it 30? Is it 30, 257? No, my goodness, no. It's 302,575,350. That's how many different ways that you can win. 302 million ways. That's just the denominator. Okay. How many ways can you win?
This one? None.
If you buy one ticket, how many ways can you win?
None, because I can't buy it.
You can buy one. Yeah, now this is written for college kids. You could buy.
Oh my goodness.
If you buy one ticket, then that is one chance out of 302 million ways.
That's a big number.
Mm-hmm. Okay, now here is the hard part of this. So this second part of this question, the denominator stays the same. However, I can win more than one way. So if I match 4 of the 5 numbers, so how can I do that? Okay, how many ways can I win 4 of the 5 numbers and not the Powerball? Okay, so here's what I got. I need to win 4 out of 5. So I need to do a combination and how many ways can I get 4 out of 5? Times, then I got to make sure there are 65 wrong numbers. I need one of those 65 wrong numbers. Right? There's 70 numbers. 5 of them are right. I need to be able to get 4 of them out of that 5. And then I need to get one wrong one. And then I need to pick one wrong one from the 24 that are wrong of the Powerball. So kind of think of it. There's 4 of my numbers. So there's 4 that are right. There's 1 that is wrong. And then the Powerball has to be wrong. Well, there's 24 numbers that are wrong, and I got to pick one of those. So this is combination 24, 1, which is just 24. So combination 5, 4 is, I think that's just 5. There's only 5 ways to do that. I better check. Sometimes I get ahead of myself. On menu, probability, combinations, 5, 4. But all right, there's 65 ways to pick the wrong ball, and there's 24 ways to pick the wrong Powerball. So 5 times 65 times 24. 5 times 65 times 24. So my numerator is 7,800. and it simplifies to 52 over 2,017,169. Still wish I could go to a decimal. It's going to be a very small thing. It's probably put in scientific notation as well. I'll have to ask somebody down the hall how to do this. So this right here is the hard problem. That's on your homework and everything. And I think it's hard because this numerator is really weird. Because you got to get 4 right out of 5 that are right. You got to get 1 wrong out of the 65 that are wrong. And now right, and then you have to get 1 right. No, you have to get 1 wrong from the 24 that are wrong. Okay. Not a fan. You will not see this on my test, but you'll see in your homework.
The other ones are easy, not that one.
So far. So far. Now, now this is the ones I do like, and these are a little bit harder. So, but they're all the same. It's the same exact question, just written different ways. Okay. So we got a sales team of 8 women and 4 men, and we're going to pick 4 of them to attend a strategy meeting. Okay. What's the probability that 2 women and 2 men are picked? Okay, so the denominator is everything that could happen. Well, we're doing this combination. We're choosing 4 people out of a group of 12. Don't worry about their gender in the denominator. We don't care. So menu 5 combination 12 comma 4 is 495 ways. It's almost a small enough number that if you had a couple hours, you could actually write everything out there. Give all 12 people names, and you can decide who gets in all the 495 different ways. Okay, now the numerator. We're going to select 2 women from 8 and 2 men from 4. So if you remember from your combination permutations lessons, so if I need to pick 2 women. So that's a combination 8 comma 2. And I need to pick 2 men. Doesn't matter which they are or the order. Combination 4 comma 2. So I'm picking 2 women. I'm picking 2 men. And any pair of women can be paired with any pair of men, right? So we're going to multiply this. So 8 choose 2, or 8 combination 2. Menu 5, 3. 8 comma 2. You guys can be faster than me. It's 28. There's 28 different ways to pick 2 women. And 4 comma 2 is 6. There's 6 ways to pick 2 men, and we're going to multiply those. So 28 times 6 is equal to 168 different ways. So the probability of 2 men and 2 women is equal to 168 over 495, which does simplify. 168 divided by 495. So 56 over 165. 56 divided by 165 is 0.339. Okay, so there'll be a lot of problems just like this, that figure out what the denominator is, figure out what the numerator is, do your division. This is the last page? Okay. But these are the exact same,
Not hard.
no, the exact same problems. So we're gonna do, I'm just gonna do one more and I'll stop. No, they're weird. They're somewhat weird.
There's some stuff I have to like.
Yeah. And this is on the final. This is on my test. So I mean, just make sure you can do these types of problems.
Most of the stuff isn't hard. It's just remembering.
And we've overwhelmed you, and now we're going to try to figure it out. We're okay. We're all right, I think. Here comes the denominator. We're picking 3 men. I mean, no, we're picking 3 people. 3 people, a group of 10. So 10, choose 3. Menu, 5, 3, 10, comma 3. There's 120 different ways that you could pick 3 people out of 10. That's not a whole lot. Okay. Now find the probability that the group consists of 2 men and 1 woman. All right. So the numerator, 1 woman. So combination. Here's the men. Out of the 6, we want to pick 2. And the women, out of the 4 women, we want to pick 1. Well, I know what that is. That's 4. And 6 combination 2 is 3 times 5, 15. So that's equal to 60. All right with that? Menu 5, 3, 6, comma 2. Okay. So it's 60 over 120, which is 0.5 or 1/2. Once again, for those who are listening at home, on the final, this is on my test.
I didn't do this. Actually, I don't.
You have to use the formula.
I don't want to know.
Yeah. And the formula is given to you on the formula sheet. So, but every calculator that I know has this. Even probably your Google ones. I want to change this last one. Ready? City councilman has 6 Democrats and 4 Republicans. Okay? We're going to pick 3 people. Okay? And what's the probability of all 3 Democrats and change it to 0 Republicans? Which would make the Republicans mad. Hey, we're having a committee, and how come no Republicans are on this committee? What's the probability of that actually happening if it was randomly selected? So I've changed this problem up. See if it's weird. So we're going to pick 3. So the denominator is the same from the previous one. It's a combination. 10 people, I'm picking 3. Okay, so then the numerator. I want to pick all 3 I'm going to pick 3 Democrats. So combination from the 6 Democrats, I'm going to pick 3, and from the 4 Republicans, I want to pick 0. All right, so I think combination 6, 3 is 20. And there's only one way to pick 0 people from 4. So this should equal to 20. So 20 over 120 is equal to 1/6, which is 0.16. Repeating, or 0.1667. Strange? Is that a small number? Is that a big number? Do the Republicans say, hey, that's cheating? Is that true? Well, it does happen about out of every 6 times you make a committee. If you pick these names from a hat, it does happen about 1 out of 6 times, which is not really that strange. So, but it does get on the paper in the newspapers.
Oh yeah, because it's Friday.
All right, so that's it for 11.5. We'll do 11.6 on Thursday. Review on Monday. Test next. No, we'll do chapter 12.3 on Monday. Review on Wednesday and test towards the end of the week. Next week. That's the plan.